In this lesson, you're going to learn all about using triangle inequalities to compare the lengths and the angle measurements of different triangles. When we talk about an inequality, we have the greater than sign, the less than sign, and then also the equal to sign, the equality sign. And these are the three that we're going to use today. Keep in mind that yes, we do sometimes talk about angle measurement, and it's easy to mix these up, but try not to make that mistake. We are talking about inequalities in this case, so just be aware of that. And the first thing we start with makes a lot of sense, and that's that the largest angle is opposite of the largest side of a triangle. And I mean, basically, if you have to open up the two sides of a triangle the most, well then you have to connect it by the largest or the longest side. Similarly, if you have the shortest or smallest angle, then that corresponds to the shortest side. Shortest angle is always opposite shortest side. To formalize this idea, we can look at two different theorems. And these basically say that if you have a longer side, AB is 8 in this case, is longer than BC, which is 5, then the angle associated opposite of that side, so in this case angle C, must be of greater degree or greater measure than the angle opposite the shorter side, which is angle A. So formally, AB is greater than side BC, so the opposite of AB, the opposite angle, the measure of angle C, must be greater than the measure of angle A. Similarly, if you're working with the opposite direction, if you start with an angles, the greater angle correlates to the longer side, and the smaller angle correlates to the smaller side. So, if the measure of angle A, which here is 50 degrees, is greater than measure of angle C, which is 30 degrees, then the opposite angle, or opposite sides, BC, must be greater than AB. Putting these theorems to work, we can order these from smallest to largest. So we're going to list the sides and the angles from smallest to largest. 8 is smaller than 10, which is smaller than 14, so that's the order we're going to look for. And these are side lengths. The side length 8 is side DF, which is less than side length 10, FE, which is less than side length 14, DE. It's pretty easy to determine this. And the angles are going to go in the same order because the shortest side correlates to the smallest angle. So in this case, DF is opposite of angle E. FE is opposite of angle D. And DE is opposite of angle F. We can also be given the angles and asked to do the same thing. Again, we're going from smallest to largest. We have that 37 degrees is less than 45 degrees, which is less than 98 degrees. So, 37 degrees corresponds to the angle Z. We can also start from an example where we're given the angles of a triangle. 37 degrees is less than 45 degrees, which is less than 98 degrees. So putting those angles in order, we've got angle Z is smaller than angle X, which is smaller than angle Y. The sides then would correlate to the sides opposite of each of these angles. So the side opposite of angle Z is side YX or XY, it doesn't really matter. Opposite of angle X is YZ or ZY. And opposite of angle Y is XZ. The triangle inequality theorem is a good way to check if lengths of given sides actually come from a triangle. And what this says is that whenever you add two of the sides of a triangle, it's always going to be greater than the third side. So for example, AC plus BC must be greater than AB. So in order to reach the length of AB, the other two sides have to be greater than that, have to exceed it to be a triangle. let's put this to work with a couple of different representations. So the check here is, well, does 3, 4, and 5 represent the sides of a triangle? Would those be okay to use as sides of a triangle? And let's check. 3 plus 4 is equal to 7, which is in fact greater than the third side that was unused, 5. 3 plus 5, the question is that greater than the third side? Well, 3 plus 5 is 8, which is certainly greater than 4, so yes, it is. And lastly, 4 plus 5 is equal to 9, which is definitely greater than 3. So in this case, this works out in all three, so check, yes, this is a plausible triangle side length, a 3, 4, 5 triangle. In this second example, we start doing our check, and 2 plus 2 is equal to 4, which is not greater than 5. In fact, it is less than 5. So because of this, these cannot be the lengths of a triangle. And visually, we can represent that. Let's say this is a length of 5 as a side of a triangle. Well, if we take the other two lengths, 2 and 2, it doesn't quite reach the third length. 2 plus 2 is 4. It's never quite going to reach 5 with being a triangle. So this is not a triangle. Using the triangle inequality theorem, we can actually find plausible lengths, or okay lengths, for a third side of a triangle. Let's take a focus on this formula written out in between. AC plus BC is equal to AB. What I want to do is solve for AC. So I can subtract BC from both sides. And what this gives me is that AC is greater than AB minus BC. So notice what we have here. The sum of two sides is greater than the third side, and the difference of those two sides is less than that third side. We can use this property. So to find this third side, the unknown side of this triangle, so we have two sides, 4 feet and 12 feet. What I can do is add 4 plus 12 and say that the addition must be greater than the third side, and we'll just call that side x. We can also then subtract these two sides, 12 minus 4, and say that this must be less than the third side, which we call x. So 4 plus 12 is 16 is greater than x. And 12 minus 4, 8 is less than x. So another way to put it is that 16 exceeds the value of what this third side could possibly be. So the third side must be less than 16. And 8 is less than the allotted amount for this third side. So to write this out explicitly, x must be between the values of 8 and 16 in order for this to be a triangle. And we can check our findings. Take the value of 9, for example. 9 plus 4 is 13, which is greater than 12. 9 plus 12 is greater than 4. And 4 plus 12 is greater than 9. So that would work out. In particular, any values between 8 and 16 do work out. But notice, 8 and 16 are not included because if we choose those values, 8 plus 4 is actually equal to 12. It's not greater than 12. So these values are not allowed. So it's any values in between. If we were working with whole numbers, that would mean 9, 10, 11, 12, 13, all the way up to 15 before getting to that value of 16. So these would all be the whole number values for that third side.